Following example, we're going to solve with integration by parts. Since the numerator has 4x plus 4, so linear expression, and the denominator is cubic, we can begin the integration by parts directly. We'll start by factoring the denominator, and the common factor is x squared plus 4 can't be factored, so we leave it like that. And we notice we have a quadratic term in the denominator. So when we break it into its two parts, we get something over x plus something over x squared plus 4. We can put a constant over x. Over x squared plus 4, we need a linear term. So bx plus c is an unknown linear term, leaving us with the job to find a, b, and c in order to try to integrate the remaining pieces. So we'll begin just as we did with linear and repeated linear expressions. We're going to multiply both sides by the denominator, so we end up with 4x plus 4 equal to a times x plus 4 x squared plus 4 plus x times bx plus c. Now we can expand here. We're going to solve this a little different than we did the previous ones. Up to now we've been letting x values be whatever we choose, whatever will help us. In this case, we would choose 0 first to make this term disappear. In this case, we're going to actually do something called equating coefficients. Basically, what that means, as we multiply this out here, is whatever the coefficient of, say, an x term is on the left, the combination of all the x terms on the right has to be the same. So if we simplify by collecting similar terms, so in this case the squared, in front of the x squareds we have a plus b. We have cx, and we have 4a. So let's just repeat a little bit what we did here. We multiplied by a, multiplied in with the x, getting these 4 terms. Then we collect, okay, we have x squared and x squared, so we factor out the x squared, leaving a plus b. The only x term is cx, so we have that, and 4a is our only constant. Now what we can do is say, okay, for the x squared term, on the left, we don't have an x squared term, so it's 0. On the right, that's a plus b. So 0 has to be a plus b. For the x term, on the left we have 4. On the right we have c. So c equals 4 is our first value. And then we have for the constant, on the left 4, and on the right 4a, and that tells us that a has to be 1, meaning we can put 1 in here. 1 plus b has to be 0, which tells us b has to be -1. And there's our 3 unknowns, a, b, and c. Taking our integral then, and integrating the two pieces that we now have, we end up with the integral of 1 over x dx, replacing the a with 1, plus the integral of minus x plus 4 over x squared plus 4. dx. 1 over x dx, well, that's ln x. And we have a little more difficulty integrating this. The derivative of x squared plus 4 does not give us negative x plus 4, so u substitution is not going to work. But what we can do is actually write this as two integrals, minus x over x squared plus 4, and 4 over x squared plus 4. Now, if we continue, we have ln x. We can now integrate this part, because now this is u substitution. U is the denominator, 2x dx. The top we have minus x dx, so we end up with minus a half ln x squared plus 4. If you can't follow that part, do some more practice with u substitution. But we still have this integral here. And that integral is going to require a little more work. This is actually a tan inverse integral. We can simply look it up in a table and write a formula, or we can actually work it out. And since in class I just gave you the formula, maybe here I'll just work out exactly what that is. So if we just take that and just work down here with it, the integral of 4 over x squared plus 4x, or 4 dx. First we're going to factor a 4 in the denominator. If we factor out a 4, we end up with x squared over 4 plus 1 dx. That's going to make our 4's cancel here. And continuing, if I write it this way, x squared over 4 is x over 2 squared plus 1 dx. So all I've done is factor to 4, and then I wrote x squared over 4 as x over 2 all squared. Now I'm going to set u, I'll do this in a different color, u equal to x over 2, meaning du is going to be dx over 2, or 2 du is dx. And if I substitute in then, this is going to give us 2 times the integral of 1 over u squared plus 1 du. 1 over u squared plus 1, that you should recognize as tan inverse. So that's actually 2 times the tan inverse of u, which is x over 2 plus c. So I'm going to take that then and stick that up here, since that's the integral we just worked out. And that's going to give us 2 tan inverse of x over 2. Now, if you check the results, if you saw me do this in class, I just gave you a formula for that, and this is what we got. I think I actually wrote 4 over 2 and left that alone, but that's fine. 4 over 2 is just 2. But we can, with a little work, show why that's true. Like I told you though, for any tan inverse integrals where this is not equal to 1, I would give you the formula on your formula sheet, so don't worry too much about this, but it's certainly not beyond what you should be able to do.